it's usually derivatized. First thing the cell would do would be stick a phosphate on the number 6 carbon. So phosphate esters are all over the place in metabolism. Phosphate esters of simple sugars. It kind of locks the sugar inside the cell, for one thing. Glucose is small enough and it's neutral that if it's in high concentrations inside the cell, there would be a certain amount of leakage through the cell membrane. But if you then phosphorylate it, it's got negative charges on it, it doesn't get through the membrane nearly so easily. So phosphorylation of carbohydrate metabolites kind of locks them inside the cell, for starters. Another way you can have derivatives of monosaccharides is to oxidize the aldehyde group, like that aldehyde at number 1 of glucose. You can oxidize it to carboxylic acid. You get sugar acids, as they're known. We'll see some structures in the next slide. And you can also reduce the aldehyde function to an alcohol. And that's where you get sugar alcohols like sorbitol and mannitol. So here's what happens. Here's glucose where the number 1 carbon, which is supposed to be an aldehyde, has been oxidized to the level of a carboxylic acid. That's glucuronic acid. You can oxidize number 6 carbon too, and there's even forms where you oxidize both 1 and 6. Those would be sugar acids. Technically not a carbohydrate anymore because carbohydrates don't have acid functions on them, but so we call them sugar acids. Sugar alcohols are more familiar, things like xylitol, mannitol, myoinositol. These are sugar alcohols that show up in food products. Gum, yeah. Mannitol, xylitol, these are in so-called sugar-free gums. They taste sweet to us, but technically they're not quite pure sugars anymore. They're sugar alcohols. And so instead of a aldehyde group up here at CHO, you've got CH2OH. You've reduced this carbonyl, got another hydrogen, and now this is